This is the last session where we're competing with another session. This is the approaches. We have a number of talks, 6 talks today, the first of which is by John Hughes, based here in the UK, comparing predation pressures of common MYNAS with those of cats and rats on seabird breeding on Ascension Island, South Atlantic.
Thank you. My aim this afternoon is to share some of our data that we've collected over 25 years on Ascension Island. On Ascension Island, the seabirds are predated by rats, not common rats, but black rats, feral cats, and mynah birds. And we've been able to equate the predation from these 3 invasive species. Many of you will know where Ascension Island is, but for those who don't, it's a small, barren, volcanic island situated in the middle of the tropical Atlantic Ocean. It's isolated, and its nearest neighbour is St. Helena Island, which is 1,400 kilometres southeast. I know the island well. I first worked on the island in 1976. The island is an important bird area, and last year 50% of the territorial water around the island was declared a no fishing area, a marine protection area. Numerically, 97%, and this is an important figure, of seabirds that breed on the main island of Ascension are sooty terns. With the help of more than 50 members of the Army Ornithological Society, we have monitored this seabird. Field seasons last about 2 weeks, and we plan to arrive on the island at the height of the sooty tern breeding season. Sooty terns are a migratory species, and on Ascension Island, they breed subannually. 9.6 months is their breeding cycle. Okay, so when the sooty terns are on the island, there's plenty of food for predators. When they're off the island, pretty lean times for the predators. Our monitoring program of sooty terns began in 1990. Feral cats were eradicated from the whole of the island in 2003 and from the sooty tern colony in 2002, halfway through our study period. So we have 12 years of data before cats were eradicated and 12 years of data after cats were eradicated. And this gave us a good opportunity to evaluate levels of predation from cats and rats. During 9 breeding seasons and more than 473 man-days on the island, prior to cat eradication, we never saw any sign of rats or rat predation in the tern colony. Following the eradication of cats, we saw a dramatic increase. We saw mynahs in the tern colony on nearly every visit to the colony. And we identified that they were predating sooty tern eggs on our very first season in 1990. Mynahs depredate many more eggs than they consume. 40% of the depredation is pricking eggs without eating any of the content. That big pile there, and 40% is causing sooty terns to desert their eggs. We monitored egg predation by marking eggs and following their fate. Mynah predation was easy to spot, like on this photograph here, but rat predation was more difficult, and we had to look for miss eggs. Miss eggs are normally taken to hides by rats and eaten there. 22% of chicks that we ringed in 2005 were predated by rats. And in 2009, we estimated from counts of carcasses in quad rats, and then scaling up to the total area of the colony, that 20% of chicks were predated by rats. Cat predation is easy to spot. At the start of our visit, we cleared the whole of the colony area of dead birds and then revisited every 2 days during our field season to count the number of fresh corpses. 1,100 cats were culled during the cat eradication program, but only about 50 of those were actually in the Tern colony. We completed censuses of MYNAS, and there were about 1,000 MYNAS on the island. I purchased 50 rat traps and carried them all the way to Ascension Island so that we could actually monitor relative rat abundance in the Tern colony. And prior to cat eradication, the lowest figure was 0, and post-cat eradication, we got up as many as 74 rats per 100 trap nights. So quite a big difference there. So here I've summarized predatory pressures from MYNAS, rats, and cats. But the real question is, which is the most damaging? 26,000 eggs, 20,000 chicks, or 5,800 adults? To answer this question, I have used eggs as the lowest unit to represent all Tern life stages, and I've calculated the ratio of eggs to chicks and eggs to adults. So the ratio of eggs to near-fledged chicks, those taken by cats, was calculated from density counts of eggs and density counts of near-fledged chicks. And the ratio worked out at 4 to 1. 4 eggs represent 1 chick taken by cats. The ratio of eggs to half-grown chicks, those taken by rats, was calculated by taking the average of near-fledged chicks and the nesting survival rate. The ratio worked out at 3 eggs per chick taken by rats. With the effort of our ringing team, who ringed 23,000 sooty terns and then recaptured over 3,500 of these across 13 breeding seasons, we would have been unable to calculate the ratio of eggs to adults. But the ratio we calculated was 10 eggs to 1 breeding adult. So this slide shows the predatory pressures on sooty terns using eggs as the common unit. During the predator regime of MYNAS, rats and cats, the total level of predation on the sooty terns was 97,800 eggs. And during the predator regime of MYNAS and rats, the level of predation was 95,000 eggs. Eradication of feral cats has reduced predatory pressures on sooty terns by equivalent of 2,800 eggs, or approximately 2% of all eggs. However, during this period, 13% of eggs were taken by MYNAS. To confirm our findings that eradication did not reduce predatory pressures on sooty terns significantly, we compared the sizes of the sooty tern population before and after cats were eradicated. During the study period, we completed 26 censuses of sooty terns. 9 of those censuses were completed before cats were eradicated, and 17 after cats were eradicated. The filled columns on this graph is censuses that were carried out in the predator regime of cats, rats, and MYNAS. And the open columns are those conducted in the predator regime of just MYNAS and rats. The population graph supports our findings that the level of predation in the tern colony during the predator regime of rats, MYNAS, and cats was little different than in the predator regime of just rats and MYNAS. To summarize, on ascension, MYNAS predate about 1/3 the amount of sooty terns that feral cats predate, and also 1/3 of the amount of predation you get from rats when rats are the apex predator. But when rats are mesopredators, in other words, when cats are around, then MYNAS predate 30 times the amount of sooty terns that rats do. Thank you for listening. Any questions?
Thanks, John. Any questions for John? Oh, we got one here. Just wait for the microphone to come around. We have. Thank you.
Thanks, that's great science. If the rats were to be eradicated, what would the anticipated level of predation be for the MYNAS? Are the MYNAS in any way restricted in their numbers now? Would they increase further, given that you're saying that there's only an abundance of food during the time when they're breeding?
Well, MYNAS have the big advantage of able to move away from the sooty tern colony to other parts of the island where there are food for them, in particular the rubbish dumps on the island. So that makes a whole lot of difference in whether the MYNAS numbers will go down. But there are colleagues here who have been on the island and have eradicated about 1/3 of the number of MYNAS that are on the island. So that's good news.
We have time for one more. Any other questions for John? I have one actually, just with regard to the removal of the MYNAS. Obviously there's intention to do an eradication, but what is the plan relative to the rats? Are they sequentially, or what's your plans?
I'm not aware of any plans to eradicate MYNAS or of rats. I think it's all down to money, and there isn't any money.
Great, thank you very much. We have a next speaker here. Denise Knapp with the Santa Barbara Botanical Garden out of California. Do we need a paradigm shift to turn the tide of plant invasions when eradication is not feasible?
Thanks, Greg, and greetings, everybody. My co-authors, John Knapp is in the audience. He's from the Nature Conservancy, and Karen Nikolakakis from University of Wisconsin, Green Bay, wish to pose this question. And I wanted to start just with a quote from the 2002 Island Invasives Conference, where Dan Simberloff said, "In fact, we are not doomed to the biotic homogenization of the Earth, but we will surely lose this war if we do not aim high." I think it's helpful to continually remind ourselves why we're doing this, why we're controlling all these invasives, and of course it's been said, islands have such high biodiversity, many endemic species, many of them endangered, such as the island fox and the island lotus that have been recovering following eradication on the California Channel Islands. It's interesting that looking at the previous proceedings, eradication efforts mostly target invasive animals, though. So you can see in 2002 and 2011 that only 31% and 8% of the papers produced addressed plants. That's of course not because they're not a problem. Plant invaders alter disturbance regimes, they alter nutrient cycling, they alter energy fluxes, and they're a key source of biodiversity decline. And typically we tend to think that these invaders like tamarisk and purple loosestrife that get very abundant have the worst impact, but that's a question. In addition, animal removals often result in their ecological release. Yet plant eradication can be even more difficult. I think of it as a marathon versus the sprint of animal eradications. The image on the left here, Methuselah, shows a date palm that was germinated following from a 10,000-year-old seed. Luckily, we're not dealing typically with this kind of seed longevity, but it is one of the biggest challenges to plant eradication attempts, as these previous publications have talked about. So eradication may simply not be possible for more extensive populations of weeds, but while better, is it absolutely necessary? So briefly, I'll present the results of a meta-analytical synthesis of data, basically just compiling a bunch of papers and seeing overall what are we finding, looking at the effects of plant invasions on invertebrate diversity. And focusing on invertebrates because, of course, they're such important indicators in the system, such vital ecosystem components performing such important functions as nutrient cycling, seed dispersal, predation, and even herbivory, which helps maintain diversity in the system. So 52 studies were found and had the proper items to analyze them. Methods include looking at the effect size, which is the natural log of the mean of the exotic over the mean of the native diversity. And in particular, we were interested in the effects of the cover classes of these invaders. So we looked at the papers and found natural breaks in what they were reporting, and these are the cover classes that we used. And what we found is that overall, invertebrate richness was 31% lower in invaded areas, unsurprisingly. But particularly interestingly, the effects were significantly negative after 70% cover was reached. And what you're seeing on this graph here is the dotted line in the center, the 0, is the effect size. If the error bars are on one side or the other, you're seeing a significant effect. And a significant effect was only found after 70% cover was reached, and you can see the high variability prior to that. A likely cause is that plant and invertebrate diversity are strongly related. This has been shown multiple times in the literature, and you can see it on the graph on the left. The graph on the right shows the effect as invasive grass cover increases in this particular study, and it shows the change in invertebrate herbivore richness. And what they found is that this is closely tied to the changes in plant diversity. So at the beginning, the plant diversity and the insect diversity actually increased, and then it decreased at higher levels of cover. So the implication here is that by removing at least 30% cover of these invaders, we're greatly improving biodiversity conservation. We are improving the plant diversity, which begets the invertebrate diversity, which begets the birds, the herps, and the mammals. So, but this kind of long-term control has been called maintenance management, and you may say, no way, we've got plenty to do already. Two reasons to consider, however, holding that 70% line is, for one, it will buy time for the island's herbivores to adapt to use those invaders. And secondly, it will allow us to continue improving our control techniques. So first of all, there are barriers to the use of introduced species. It's one of the reasons they're so successful. It includes nutritional quality, the plant architecture, the chemistry, the habitat structure, and even simply just behavioral constraints that these insects are not used to using these new taxa. But these barriers do break down with the residence time of the invader in the system. This has been shown with individual studies, and in my meta-analysis, when I used this as a covariate, I did find that with increasing residence time, the effect size approached 0. You can see the high variability, however, in this. So as these insect herbivores are adapting, our control techniques are evolving and improving as well. It includes utilizing aerial surveys and even transportation to control these weeds. It includes improvements in our hygiene to avoid vectoring the weeds more. It includes experimentation to improve our techniques, whether that be new herbicides, heat treatments, fire, or even now robots. It involves targeting multiple species at one time to improve our efficiency. And it includes better mapping systems like in the aerial survey tracks that you see in this image of Santa Cruz Island. You may still not be convinced that we need to put our energy into this. Of course, we have limited funding, and this is an enormous challenge, and it will be an individual decision. But I ask, when we've removed the animal invaders and we've removed the low abundance plants that we can eradicate, do we then just consider our job done and walk away? So I present a case study from Santa Cruz Island, California. It is the largest of the 8 California Channel Islands and the most topographically diverse, and thus it supports diverse plant habitats, diverse plants, animals, many endemic species such as the island fox and the island scrub jay. On that island, invasive animals have been removed one by one since the 1980s, including sheep, pigs, wild turkeys, peacocks, horses, cattle, European honeybees, and most recently, Argentine ants are in process and within our sites. In addition, 32 invasive plants have been targeted since 2007. This started with a complete aerial census of the island, and that the helicopter survey tracks there are the coverage of the island. Then it involved prioritization of particularly the low abundance and high impact weeds, and then targeting the 15 top tier taxa, and then moving to the 17 second tier taxa. And as you can see in the images there, this is remote and difficult terrain. So this has resulted in numerous plant control successes. Those first 15 species were controlled to 0 density over the whole island. This includes grasses, trees, and then subsequently when those were under control, the second tier of 17 species was controlled to 0 density for 90% plus of their infestations. This, of course, was not without challenges. There was a couple of problem children in particular, Euphorbia terracina and Helichrysum petiolare. In these cases in particular, they were unable to outpace the reproduction, but removing these weeds has resulted in natives coming in and an improvement of habitat. And then you might already be aware of the poster child for Santa Cruz Island, fennel, Feniculum vulgare, which came in quite heavily after cattle and sheep were removed on the island. But as you can see from this map here with the big green populations, it still covers a large part of the island and is having major impacts. So TNC is evaluating the management strategies for this plant. And what the meta-analysis research suggests is that perhaps in these high-density areas, limiting the fennel's density while also curtailing its spread on the fringes and trying to eradicate the satellite populations may help achieve their conservation goals. So in conclusion, we are, after all, here to conserve island biodiversity. Invasive plants are as much a threat as animals, but they're often more difficult to eradicate. And our research suggests that a little control may actually go a long way and buy us some time to limit the damages. So for invasive plants, perhaps eradication is not the only sensible option. And I am heartened by all the talks that talk about involving the community and utilizing that labor force and involving them in protecting the biodiversity of their home. And I think that that's something we can focus on more in the future. And thank you for all of you for all the work that you're doing on these islands.
we have any questions for Denise? Some of the work? We have one in
Crystal
the
clear,
back.
huh?
If you just wait for a microphone there.
All right, thank you.
Hang on, Denise, we got one in the back here.
Where's the question?
Oh, yeah, okay. I was interested in your figure there about plant cover, invasive plant cover, and the diversity
Right.
issues. How big were the kind of plots that they were done on when you're talking about reducing, 7% cover, etc.?
Right, well, because this was a meta-analysis, it involved a whole lot of different studies, and the methods were often quite different. So they had a whole variety of methods, and I can't say there was any, typical one used.
And were they from a wide range of areas,
Yeah,
regions?
they were from worldwide. Yeah. All right, thanks.
I have one question actually for you.
Yeah.
I'm just curious about invasive plants in the California Channel Islands. Is there any success removal of invasive plants at all, either a new invasion or an established population?
A whole lot of successes. John and his crew have been doing a lot of good work, and those 15 at least have been controlled to zero density. They continue to go back to those populations, and then they've moved on to a bunch of others. John, anything more you want to say about that? Yeah.
How about the ice plant on Anacapa, an island special to me?
Yeah, well, that covered so much of Anacapa. They're making great progress on that. It's not done.
Yeah.
So, yeah.
Great, thank you.
Thanks.
Thanks very much. All right, our third speaker, we have a student from Italy, Daniele Carey. He's going to be talking about in modeling invasive plant alien species richness in the Canary Islands using some statistical modeling. Thank you.
Good afternoon to everybody. In Europe, we have more than 12,000 alien species, and more than half are terrestrial plants that directly affect the natural European species. And as recalled many times in these days, 50 of the 80 documented plant extinction occurred on the island in the last 400 years. And this trend is particularly enhanced in Macaronesia, which is the geographical region that encompasses Azores Island, Madeira, Canary Island, Cape Verde. And our work is mainly focused on Canary Island, and in particular on the biggest island of the archipelago, Tenerife. Canary Island have a long experience about biological invasion. In fact, when Guanchi arrived and colonized the island around 500 before Christ, they brought with them goats and wheat. And well, after some centuries, the first European established a permanent settlement, Lancelotto Malocello, in 1312, definitely opened the way to the conqueror of the Castilians that brought with them new alien species. Nowadays, the main source of alien species in Canary Island is tourism, and inside the island, the pathway for the dispersal of plant alien species are roads, while between island are boats and planes. Well, in Canary Island, we have more or less 700 introductive species, and on Tenerife Island, we have an overall the higher amount of introductive species because it's the biggest island or archipelago. And in our work, we use the Atlantis database, which is a grid of 500 times 500 meters that cover the entire archipelago. And we select all the cells that cover overlap Tenerife, and where we found 72 plant alien species with a mean of at least 4 species per cell. Well, we can, okay. So we can simplify in 5 main vegetational belts the different habitats of Tenerife. We have a arid subtropical scrubland, a semi-arid temperate subtropical scrub, a humid belt where we can recognize the famous laurel forest in the mountain of Teno, La Rotava, and Anaga, Teno, and La Rotava, temperate pine forest, and a dry subalpine scrub. Well, in the arid belt, we can observe the difference between the northern part of the island and the southern part of the island. And here the most common plant alien species is Penicetum cetaceum, while in the subtropical belt we have an increase of the humidity, and we have here as the most common species, plant alien species, Opuntia maxima. In the humid laurel forest, alien species occur only in open patches because it's difficult for them to establish in under a dense canopy, and Oxalis pescapra is the most common alien species. And a similar pattern is observed in the pine belts, where due to the dense canopy, Scholze californica, the most common alien species, plant alien species, is we can find it just near road. While in the dry scrubland, over 12 to 2,000 meters, the most common alien species is not a plant, but rabbits. Well, the aim of our study was to use an island that has open air laboratory to understand the different role of ecological driver in determining and shaping the alien species richness, the spatial distribution, and to understand the effect of the spatial autocorrelation of data in the model. In particular, a land manager needs an easy, understandable tool to detect and direct eradication and conservation efforts. And in this case, maps are the perfect tool because they are easily understandable and can simplify complex pattern. But it's pretty easy to build a map, but not often we take into account the spatial autocorrelation of our data, and also we don't often report a map of uncertainty of our prediction. And in this case, the generalized linear spatial model allows to reach both of those goals. And in our framework, in an open source framework, we use GIS data and spatial analysis and weather station data and co-creating to obtain a continuous representation of environmental phenomena. We collect the predictor and we reduce their number in order to reduce the collinearity between them. We estimate the spatial component of the alien species richness response variable, and when we try to build up the generalized linear spatial model, we have problems with the convergence of algorithms, so we decide to move into a Bayesian framework in order to select the predictors due to prior knowledge. In particular, the predictor we select are elevation due to the well-known negative relationship between plant alien species and elevation, and spring precipitation due to the amount of water that fall in winter and spring can enhance the performance of alien species. And finally, we select a road canal density as a proxy of tropical dispersion and anthropic disturbance. Our results, first of all, show that incorporating the spatial component in the model decrease the AIC. So our model seems to perform better than a non-spatial model, while we have found a strong relationship between road canal density and the invasive alien species richness, where we can find more alien species at in a heavily dense roaded area, and most of our roads fall below 1,000 meters, and this is supported also from the negative relationship with the elevation, while a positive relationship was found with precipitation. This means that in Tenerife Island, the community of plant alien species prefer lowlands, so these arid belts and subtropical belts, with higher anthropic pressure and moderate apport of water. And our map of the prediction highlights the western part of the coast of Tenerife and the northern part, which are the part of the island where that benefits from the trade winds, and where the most important cities of the island are present. So here this is the capital, Santa Cruz de Tenerife, San Cristobal de la Laguna, and Puerto de la Cruz. In particular, it seems that the species does not reach elevation higher than 1,500 meters, maybe due to the reduced also number of roads in that part of the area. Well, here on the right, we can observe the uncertainty map of the uncertainty of our prediction, and as a last check, we as a scatter plot of the predictor value versus the observed values, we have a quite good goodness of fit. So in conclusion, a combination of anthropogenic and natural processes mainly drive and shape the alien species richness in Tenerife, and including the spatial autocorrelation in the model considerably improves the model fitting. And the Bayesian framework allows us to incorporate prior knowledge inside our analysis. And finally, in a global change scenario, these kind of tools can be really useful for land manager to highlight and direct those areas where conservation and eradication efforts should be directed. Thank you.
Thank you. Any questions? Sorry, we got one over here. Just wait for the microphone, please.
Hi, thank you for your presentation. I wanted to ask, were there any other parameters that you were thinking about besides elevation, spring precipitation, and road kernels?
Well, sorry, I didn't understand the first part of the question.
Were there any other parameters that you were considering for your analysis?
No, in this case, we just chose these three.
Okay.
But because in Tenerife, other studies highlighted that were the most important environmental predictors for anthropogenic predictor for alien species. But we can include other parameter and see what's happened.
Okay, thank you.
Great. Any other questions?
Just following on from that question, have you thought about putting climate change in as a predictor?
No.
Or putting it in the model?
No, we don't put in the model climate change predictor. We haven't. Sorry.
Would it be possible to do it?
Yeah, sure. Yeah, maybe in the next development of this study, we can insert something. The main problem was that we make a special co-creating analysis to obtain 500 meter spatial resolution environmental data, while using, for example, WorldClim or other database that allows to use also climate change predictors. The spatial resolution was higher, and so we decided to just use the current situation.
Great. Any other questions? This time? Great.
Thank you.
Thanks to the great efficiency of our speakers, we're quite early. We have a few more minutes, so we're just going to wait until just before 2:15 before the next speaker. Only if you dance with me here. So we'll start up here in about 5 minutes. Sorry, Jeff.
Let's start with O Canada.
Start there.
I think I might do it. Sunday. Oh, I was hot.
Were you?
Yeah. Verify if it's hot. There it is. Sunday, I believe.
Okay.
Yeah, so Saturday night I'll be in Glasgow.
Okay.
And then I take off Sunday.
Oh, you're going to Ireland. You're going to Ireland. You say Glasgow?
No, it's just an hour and a half away.
Just you deliberately did that, or
I couldn't get a flight into Edinburgh. I don't know what the deal was. It just was wonky.
yeah, we flew the London thing, doing the London thing on the way back.
But you guys had business in London, didn't you? Yeah.
We'll get started in one more minute. I really meant one more minute. You didn't have to be quiet. We found a notebook, a purple notebook. I don't know if this belongs to anybody that's in the room here, but I'll have it here. We'll just leave it up on, I'll leave it over here on the table here on the floor or on the floor. Just come down and grab it. Our next talk here is from a colleague of mine from Island Conservation, Chad Hanson, who's going to be talking about a project that's been underway for a little while. We're going to go from the Canary Islands directly across the Atlantic over into the Caribbean to the islands of Puerto Rico.
Hi. So like Greg said, my name's Chad Hanson. I'm with Island Conservation. And after about 10 years, 17 trips, and almost $1.3 million, I'm proud to be here to represent my co-authors here, as well as Island Conservation in the partnership with the U.S. Fish and Wildlife Service. So we can present on our efforts to remove rhesus macaques from the island of DESECHEO. And hopefully this presentation will do well to show you why we did it, as well as what we did. So this is the island at hand. This is DESECHEO. It's about 17 kilometers off the west coast of Puerto Rico. It's 116 hectares. It's fairly mountainous. You guys might be familiar from other presentations. And it's got an elevation of 218 meters at the top there. You can see it just about right there. It's dominated by a dry forest. It's got a thick tree canopy across the majority of the island. So DESECHEO is a good candidate for restoration for several reasons. Many of them you can see here. It has 5 endemic species of animals, a number of unique plant species, including the one on the far end, which is a Haristia cactus that's threatened. And it also has birds, has a lot of birds. In 1900, it was described as being an island obscured by a haze of birds. And it's the largest seabird breeding colony, at least it was, in the region. That's no longer the case since 1966. And that's when 57 rhesus macaques, which is a primate, 5 to 7 kilograms in size, was introduced as a research project. Shortly after that, researchers noted that these animals were taking roughly 200 to 300 eggs per week. And shortly after that, in 1970, it was noted after analysis that there wasn't a single breeding bird that could be found on the island, a breeding seabird. And so, in addition to that, it's since now, there's been 5 bird species extirpated, several plant species, and this animal has also been noted as eating a number of the endemic reptiles that are on island. So in 2007, Island Conservation partnered with the U.S. Fish and Wildlife Service, and we conducted a feasibility assessment for eradication. That feasibility assessment basically came away with several key findings. One of them was that there had been already 3 eradication attempts, each of which that had failed. The primary reasons were insufficient removal and detection methods and insufficient funding. Additionally, that this species can be highly intelligent and can adapt quickly to any methods utilized in towards its removal. As well, staff safety became quickly a concern of ours. So this population was pulled from another island that was known to have something called B virus. And B virus is a highly contagious, high consequence pathogen that's lethal to humans. So these principles here represent essentially what we are looking at to put towards the project. And realistically, they represent 3 things. They represent us looking at efficacy, staff safety, and eradication ethic. So as a result, we developed a 3-phased approach, which was comprised of variations of trapping, hunting, and remote monitoring. We started with trapping. 3 trap types were basically group trap designs. They relied on the use of pre-baiting. Up here on top, there's a drop net that's about 11 by 11 meter reinforced net that could be suspended and dropped with a remote control. Down below here, this is what we described as an octagon trap. It's built off of a variant that was used elsewhere successfully. Animals can get in, but once they're in, they can't get out. We also used large double-door cage traps. I don't have a photo, but many of you are probably familiar with them. They were large enough to house several animals at a time. And then a fourth trap design, which is a padded leg hold trap. These didn't rely on bait. We utilized lures, visual and audio lures, as well as blind sets. And these were set out with a remote trap monitoring system. So we found out pretty quickly, after basically roughly 450 trap nights, that the group trap design that I described wasn't effective. We had 0 trap success. Utilizing the padded leg hold trap, after roughly 1,350 trap nights, we had 13 captures. We used 3 of those, collared them, and released them as Judas animals. So some key important things about this is that the pre-baiting wasn't working, but the padded leg holds, they relied on lures, and those lures in particular relied on things that were shiny, metallic objects such as mirrors, wind chimes that made noise. And we also found that a blind set at the base of trees were relatively effective. But due to the lack of trap success, we moved on pretty quickly onto group hunting. We utilized a strategy where a field team would be in place at night. They would identify where a troop would go into a roost. The following morning, we would have a coordinated effort to triangulate a group as they're coming out, and then we would participate in removals along a hierarchy. Typically, adult females were dominant, and we worked through down to juveniles in an attempt to remove entire groups at a time, which fell in line with our principles that we had already established. This was our success rate. We removed 84% of the animals relatively quickly, basically over 2 trips totaling 46 days. We then ran into a situation where we were down to low numbers, and we turned and used another revised strategy of hunting shortly thereafter, which was basically relying on remnant hunting. This took and was looking at targeting small populations, groups of 2 or 3 that have reestablished from fractured troops, as well as removing single individuals like satellite males, which are fairly common within the troops of macaques and behavior. We utilized the same type of equipment. In particular, we had high-capacity, semi-automatic precision firearms with muzzle brakes that allowed quick follow-up shots and allowed for rapid reloading, which was critical on this project. Remnant hunting stretched out over time. Typically 1 or 2 individuals were removed at a time. 5 field trips over the total of 66 days occurred basically, and it brought that down to what we found was non-detectable levels. Days to weeks would occur between detections, and what this meant is it really required a strong eradication ethic to keep the field team basically focused, as well as not to force a poor shot, which ultimately would result in educated animals. Since we already identified, that was something that we really needed to avoid on this project. During that same time of remnant hunting, we needed a detection method. And our plan was to utilize remote monitoring. Here, many of you are probably familiar. That's a Reconyx camera. That in particular is a no-glow hyperfire, so it doesn't emit any light. It is very cryptic. And we set them up across the island. We began monitoring with this, and the placement of these traps focused on exposed areas, rocky bluffs, and horizontal limbs that our field team identified were ideal locations to get a good field of view and have fewer negative detections from vegetation moving. We checked these cameras every 2 to 9 months, so they would remain in the field for quite a while. So up to 26 cameras were installed. It varied a bit. Obviously, these harsh environments can have a serious impact on equipment. And at the highest rate, or between the highest and lowest rate, we would have a camera across the island every 4.5 to 7.25 hectares. Monitoring proved successful. We produced 450,000 photos over the monitoring phase. 2,000 of those were macaque detections. And this demonstrated that animals remained that were undetected by our field staff, which was a huge deal. And what this also signified in an adaptive management strategy is that we needed to go back and revise some of the strategies that clearly weren't providing the result that we had set out for. And so that is indeed what we did. Fortunately, concurrently, there was another primate control operation going on mainland Puerto Rico. This was being conducted by USDA and the Department of Environmental and Natural Resources. And at the time, they had just recently began integrating the use of thermal weapon scopes. And those were a high-grade, a military-grade item that integrated both a high-level, high-contrast thermal with a firearms reticle built into it. This, in addition to night hunting strategies, is what was proving successful on the mainland. And so what we did is we collaborated with this team over several trips on DESECHEO to trial the technology and to adapt a strategy that was going to work in our scenario. We also had 3 Judas animals that didn't function, so we released 3 more. And we integrated night vision and IR lasers to identify the collars with IR patches so we wouldn't remove those animals that we worked so hard to put into the environment there. So through that, we have a spike, shows that those tools were successful, another animal at the end. And basically, subsequently, after 41 months of monitoring, we had 1 wild adult macaque that had been detected on 15 separate occasions. Judas animals were demonstrating effective. They were guiding our hunting on island. And no juveniles were shot or detected, reflecting reproduction had ceased. And so at this point, a month ago, with our partnership, we worked together to identify that the population was functionally extinct and effectively functionally eradicated. Several lessons. Trapping wasn't successful for us, but it is elsewhere. Pretty self-explanatory. Macaques were quickly educated. We had to utilize new methods to target all of them. Several other lessons here. Key was adaptive management, a robust partnership. And the project lasted a lot longer than expected. It required several revisions, and as probably as expected, the budget was much higher than originally planned. And that partnership and an understanding and a transparent relationship supported us in that. In conclusion, this is the first successful non-hominid primate eradication that we're aware of. Success was contingent on these 3 aspects. And now DESECHEO is free from invasive impacts from primates after 50 years. And we have hopes that and with the work done by my colleagues for rat eradication and goat eradication, that the island will be able to return to its former status again as the largest seabird breeding colony in the region. Thank you.
Thanks, Chad. Any questions for Chad? Just wait for the microphone to come up. We have a couple questions. Do we have somebody here managing those mics? There's one fellow up in the center.
Hi there. Did you utilize dogs in any way, hunting dogs?
We considered it as one of our potential methods, particularly in the revised strategy, based on certain disinterest from the partnership and the effective use of the alternative tool that we identified with thermal technology. We put it basically further on the back burner, but it remained as an option.
Yeah, just go for it.
Yeah, absolutely. Great question. If we were able to basically attempt this project, the exact same project, we would start off with those revised methods. In fact, we feel that that would probably have reduced the project costs in half, even greater. And the timeline was 10 years, would have been reduced significantly, potentially within a couple of years.
One question, Chad. How many islands globally would have macaque?
There's a great paper coming out on that we basically been doing a review on, and it's upwards in the 60s to 70 islands. So there's quite a few. Yeah.
Great. Well, great. Thanks, Chad. Our next speaker is Peter Carey. He's going to take us from the Caribbean, still in the Atlantic. We're heading down to the Falklands.
Well, good afternoon. I'm going to talk to you about a project, the result of which we don't yet know. We did the poisoning operation to get these 3 species at the same time. Poisoning was done in September and August of last year. So I can't tell you if it worked, but I can tell you what we tried and why we were going about this. You all should know where the Falklands are by now, down at the bottom of South America, just about 500 kilometers off the east coast of Argentina. The islands have just one population center, Stanley, the capital city there on the east, and the islands that we were working on are on the western side, 186 kilometers away. So logistically, that added a few little wrinkles for us. Now, BENSE and Little BENSE Islands were purchased by the SAFER Foundation with the expressed goal of doing eradications and ecological restoration. You can walk between the 2 islands at low tide. They're connected by a rocky reef, so if you've got gumboots on, you can move between them. And certainly the Norway rats that live there will do the same. There's also house mice and the European rabbit. All of these invasives have been there for at least 100 years. What's conspicuously not there are the endemic passerines. There's 2 found in the Falklands, the Cobb's wren and the blackish synclodes, locally known as the tussock bird. And these do not coexist with rats. So one of our goals in eradicating the invasives was to reestablish populations of this native endemic bird. BENSE and Little BENSE have never been permanently inhabited. They have, however, been grazed very regularly throughout the late 1800s and all through the 20th century. They're not huge islands, about 144 hectares in total, but significantly, they're not terribly far off of the mainland of West Falkland. 750 meters at its closest point, and those of you who have seen Ken Passfield's poster down the hall here will know that that is within the distance that's thought to be easily swum by Norway rats in Falklands water. So we are aware that one of our risks is always going to be reinvasion, and we will have to have biosecurity plans to counter that. Now, the islands are not particularly mountainous or anything like that, pretty level, easy to work on, except for the north coast of Little BENSE, which is serrated like this, all these little canyons, which make things a little bit more awkward and logistically difficult, especially because this backs onto very dense tussock grass and makes it hard for people baiting by hand to get through. There's really only 2 main habitat types on the islands. There's the coastal tussock grass, seen in the brighter green at the bottom of this photo, and then inland from that you get the inland heath vegetation, which is much more of a tundra-like. And here's a person who's 1.9 meters tall, 6'2", standing in amongst tussock. Very lush, sometimes it's up to 3 meters in height, and it can be a challenge to get through in areas where it's at its densest. Contrast that with the inland heath, where you can pretty much walk anywhere you want in whatever bearing you would like to walk. BENSE Island also has a third area, which is this burned zone. It was scorched in 1985, and 22 years later, it still is a denuded zone. Nothing has regrown in here. Before we took to putting bait out, we did some basic index trapping to get a handle on the habitat preferences of the rodents. And we found that the rats, shown here with the yellow bars, really very strongly preferred the coastal tussock, whereas the mice in the orange were equally happy to be in the inland heath or the coastal tussock zone. And so we got onto the part of putting bait out to try to get rid of all 3 species simultaneously, and we were using just this one type of bait. It was donated to us by the Falkland Islands government. And they, in turn, inherited it from the South Georgia project. And for those of you here from the South Georgia project, I'd like to say thank you very much and let you know that your leftovers are being put to good use. Falklands government is, in fact, making this stuff available to private landowners around the islands who do wish to get rid of rodents. So we had to get it all out to the islands. Initially, that went by barge from Stanley, and then the latter part from the barge onto BENSE Island and Little BENSE by Ministry of Defense helicopter, and they left us with 7 depots of bait across a midline of the islands. Sadly, we still had to carry a lot of it on our backs to move bait to where it was needed as baiting continued. Obviously, we want to make sure that we're going to put the bait out in a way that every rodent gets some. So for us, with our 3 species, we went with parallel transects that were 20 meters apart instead of the normal 50 meters, with the understanding that mice move in much smaller home ranges. So the lines were a little closer together, and along each one of these transects, we had baiting points every 20 meters. And just zooming in on one part of the island, perhaps you can see the dots a little bit better. So an imaginary 20 by 20 meter grid for hand broadcasting bait, and also every 20 meters along the shoreline. We did 2 applications. The first one used 5 field staff, took 9 days, and we covered the 2 islands at an average of about 15 kilos per hectare. We were a little heavier handed along the coastline and in the dense tussock, and a little lighter handed in the burn zone where there wasn't any vegetation. It's all hand broadcast, carried around in buckets, thrown out in custom cut scoops. And we had one issue to get over, which was that we had total novices doing this work. Nobody had done it before, and we wanted to minimize the risks of not putting bait in the right places. And the solution we came up with was to not just put the transect map on a handheld GPS unit, but put audible alarms in. So the staff could then get themselves navigated along a transect, and when they hit a baiting point, an audible alarm would go off, tell them stop, throw your bait here. You do that and then carry on to the next time the alarm goes off and repeat that. And in this way, we're able to cover everything that we were supposed to cover. And at the end of a day, we could actually look at the track data to see, did you get transect 22? And if you didn't, we'd know that. And so here is the tracings left by the staff walking. The numbers just refer to where the bait depots were. The lines that cut across the grain of the transects, that's just commuting traffic. And the yellow islets that you see around Little BENSE at the top there, those were baited, but not by somebody carrying a tracker. So we did cover everything as intended, including the coastlines. And the animals loved it. They got right into it the next day. We were finding nibbled bait. And then we moved on to the tricky part, this north coast of Little BENSE, where we were lucky to have a local farmer who was willing to bring his boat in, and we could use that to go into these little canyons instead of having to fight completely through the tussock. We could approach the dense tussock from both sides this way. 10 days after we finished the first application, we started the second application. And this one only had 3 field staff because it turns out it's very hard to find people willing to go camping in the middle of winter in the Falklands. So we took what we could get, and a couple of new guys came out. And in this application, we did it 11.7 kilos per hectare, reflecting the smaller staff. We did have the benefit, though, that there was still quite a lot of bait left over from the first application. You can see the left-hand piece there. It's a fortnight old. Now, application 2 did not completely replicate application 1. We had wanted to, but with the reduced staff, that just wasn't possible. And if you look at the differences on BENSE Island, you'll see the main difference is in this zone in here. This is the burned area. And so that was deemed the lowest priority. When we realized we weren't going to be able to cover everything, we thought, well, we'll leave this for last. So we did all the coastline again, all the vegetated areas again, but we did not get a chance to bait for a second application on the burn zone. At Little Bense, further complications, not only do we only have 3 people, but 2 of us were then suffering from injuries at this stage, so we weren't able to cover the same ground. You'll note that the tracking lines on the right-hand side are much further apart. In fact, we did every second transect on application 2. We did make an effort on our lateral throws to kind of put a little more into it and throw wider on those to leave less of a gap, but that is essentially a 40-meter gap between baiting lines instead of 20 meters. And we do recognize there's the possibility of an unbaited corridor from the second application. All coastlines baited a second time, though. Sadly, there was some non-target mortality, and it's the dolphin gulls there on the top left who were the worst affected. 23 of those found. And they were the only species we saw that actively ingested the pellets, just right up, went up and ate them. All the others seem to be secondary poisoning, like this striated caracara eating a dead dolphin gull. The vultures, the owl, may have also taken secondary things, whether they were birds or mammals, I couldn't say. We don't know whether this worked. We are hoping to go out again in November. We have a trip planned, and we'll put in these standard techniques to see what's still there. We did have a brief visit in December last year, 3 months post-baiting. And while we didn't have a chance to deploy all these sorts of things, casual observations did not reveal any fresh tracks, any fresh sign of any kind, and certainly no live mammals. But that doesn't say anything. We weren't really looking all that hard. So really, this is one big step in an ecological restoration project to try to get these islands back to prime wildlife habitat. Certainly getting rid of the invasives is a huge step, but if we can accomplish that, then the next step beyond just establishing or reestablishing the endemic passerines is that we could start to get this burned area revegetated and then increase the amount of habitat that's available. If I could indulge you in just a couple of seconds here, I would like to show you a photograph of some grass that I took while we were there in December. And I would like the experts who have seen a lot more of this than I to tell me whether or not this was grazed by a unicorn or a rabbit. I'm thinking rabbit, but I'm hoping unicorn. There was no obvious signs, but there were a couple of places where we got this kind of very young grass that I don't think has been growing long enough to have been nibbled on before we laid the bait down. Thanks very much for your attention.
Any questions? Just wait for the microphone, John.
One would expect rabbits to survive, as they've done on Enderby and Macquarie and other similar islands. So, I mean, that's one of the puzzles of why you get the rats, but not some other species.
Yeah, does that look like rabbit to you?
Yes.
Any other questions for Peter? No. Great. Oh, I'm sorry, right in front of me. Thank you.
I've got a plant question, Peter. That was absolutely lovely tussock habitat there, which is a threatened biome in the Falklands. Any plans of trying to do any restoration on the burnt areas? I mean, there's quite a lot of Falklands conservation been doing a lot of tussock, replanting, regeneration. There's a lot of good expertise there, and they're growing tussock from partners.
Yeah, we would very much like to be regenerating the tussock. The area that's been burned, only the coastal fringe of that was originally in tussock, so not all of that will get naturally replanted that way, but we'd love to get that full collar of tussock running all the way around the island again. And yeah, very much part of the plan.
Any other questions? Microphone, Nicola, thank you.
I saw you had quite a number of casualties among gulls, right?
Yeah.
Did you notice if you had a lot of droppings on rocks or wherever, gull droppings of the color of the baits.
Yes, we did find the bait does have a biomarker in it, and so there were areas where the gulls were hanging out where we found green droppings, but like on some of the little intertidal rocks. We didn't find that away from the gull hangouts, but yes, we definitely found bird droppings.
Because my personal opinion was that on Monte Cristo Island eradication, gulls, which died in big numbers, of course, helped us a lot in spreading the poison much, let's say, even better than the helicopter, because these blue shits were very appreciated anyways by rats, also if digested.
Right. Well, hopefully that'll be working while we're here. Thanks.
Thanks very much, Peter. Our final talk of this session is by Alan Ty, coming out of ICN out of the Mauritius. He's going to try and unify us under restoration guidelines.
Yeah, for a change, I'm not going to try to tell you how to do anything according to groundbreaking innovative techniques or internationally approved best practice. I'm just going to give you a plug for something interesting to do this evening. What we want is for you to come and tell us how to do something, and the something is planning. I work at the moment for IUCN based in the Western Indian Ocean, and based on an initial request from people working on invasives in this region, we were asked to develop some kind of document to assist people beginning to work on invasive species in some way. And based on inquiries locally within the region and also via global email lists such as the Aliens List server, the idea that came up, a similar idea came up from different ocean regions, that the best area where we could focus our efforts would be to try to develop something to guide planning processes. That seemed to be a gap identified in several different ocean regions. So that's what we decided to do. We began work early last year on a draft using a consultative process by email through these list servers and also at meetings like this one. And the aim now is to complete a set of guidelines to assist planners and managers to develop invasive species plans and programs. And that ranges from people planning for a single organization or a department or a single island, right up to planning for an island country. And we hope to get this together in time to publish the guidelines by about this time next year. So the focus is really on a document that will guide higher level planning processes and decision-making processes, often carried out by people who don't have a lot of experience with this sort of thing. And this can range from things like writing a national invasive species strategy and action plan, or the invasive sections of an NBSAP, or a single organization's invasive species program, how to choose the priorities for that program, or something at a more local level. So the idea is to help make sure that nothing important is forgotten in your plan or program, and if you leave something out, it's a deliberate decision to leave it out. So part of the document that we're developing is a kind of checklist that people can use to make sure they don't forget things when they're going through a planning process. Another part of this is to make sure also that the plan that you end up with is realistic and prioritized according to the resources that you have available, or that you can easily or realistically try to get during the period of the plan. So overall, it's to help the planning, prioritization, decision-making processes become more objective and more based especially on problems that you can do something about with the available resources, and avoid wasting money on intractable problems that you can't really tackle with the resources that you have. So the Pacific has had guidelines for exactly this purpose since 2009. So this is the model we're using. The inquiries we carried out last year in the Western Indian Ocean and worldwide via aliens and other listservs, indicated a general feeling that this specific document is an excellent starting point to put together guidelines that would be useful for islands anywhere. So the current draft we have consists of 10 basic lines of action which fall into 3 main groups. This is the first group, the foundations. The first theme is planning and decision making. That's actually decision making here, we mean choosing what to do, choosing priorities. The second one, assuring support, that's all kinds of actions, including awareness, raising, to increase support and finances for the actions that you plan. Capacity building, training, infrastructure, networks, technical assistance, all that sort of thing. And finally, the legal framework, the laws, policies, regulations that you need in order to get anywhere. The second group of activities we've put under information and prioritization. This differs from planning prioritization in this tells you what you might want to choose as your priorities rather than telling you how to choose them. That comes under planning. So under information and prioritization, we've got tools to inform decision making and planning. Also, baseline information, accumulating a baseline of information and monitoring for change. So which species are present, which are the emerging problems, risk assessment and the processes and tools for prioritization such as weed risk assessment and pathways analysis. Then research on the priority problems that you select, including the biology of the invaders and developing control techniques. Then the final section of the guidelines is the action, right from biosecurity, border control, through to management of established invaders, to restoration. And by restoration here, restoration's often used by ratty people to mean getting rats off an island. But here we mean after you've got the rats off the island, what do you do if you need to take further action to restore the values that you're seeking to restore on that island. So these are the 10 main lines of action in the 3 groups in the draft that we've got at the moment. And in addition to the main guidelines checklist, if you like, we're planning supplementary sections which are based mostly how to do something, which refer to some of these sections that need particular detail added. So writing this document's a collaborative process, and we're taking advantages of meetings like this to stimulate input. So this talk's really by way of a trailer for the working session this evening, and we're seeking in your views on the draft so far, input to what from you on what you think this kind of a document ought to contain. And it's not a management manual. I must emphasize that. It's more of a guide on how to make planning decisions and how to choose your priorities and develop a realistic, objective plan that you can really helps you to make some progress during the period you're planning for. Now, the session this evening starts at 18:05 hours with military precision, following the session on the Predator-Free New Zealand 2050 and the Honolulu Challenge. And it's in room 2F11. If you go out of here, this door, head towards the stairs, and just when you get to the stairs door before going down the stairs, on the left, there's a small room there with tables suitable for breakout groups. So please do come and give us your input to this. And that's it. Thanks.
Thanks, Alan. We've got lots of time if anybody has any questions for Alan at this point, but tonight's session is also another time to make your contribution to the guidelines for invasive species management. I did want to say one thing about this, Alan. I think something like this is very important. As we move towards a world in which we have the attention of the global community, we have some interest at the CBD, at the Jeff level, funding this type of work, particularly for small and developing states, and a lot of support for implementing or looking towards the implementation of these types of programs. A lot of times they just reach out to experts that they find on the internet, find in the literature. But giving them a resource such as this to help them get started is critically important. So if you do have an interest in this type of thing, thinking about planning and making a contribution would be very helpful to maintain this interest in global funding mechanisms.
Thanks. Yeah, I should have said we'll have some printouts of the various sections of the draft available at the working session. But if you want to see it before you get there, it's on the conference website, and it's also on a memory stick in my pocket. So if anybody wants to grab me at tea, then I'll give it to you. Thanks.
Great, thanks, Alan.